Hello everyone. Today we will present our project enhancing customer orientation through machine learning using customer segmentation, trend prediction, and product recommendation. This project is a case study based on the Flipkart transactional data and the Flipkart product data. So Flipkart is one of the Indian e-commerce platform, and this business held like 48% market share in the Indian e-commerce industry. The customer orientation is one of the most important metrics in every business. But many business these days they keep the old approach, which is finding new customer instead of keeping the old high value customer. According to the Harvard Business Review, finding a new customer can cost up to like 25 times, and that making customer orientation a key business priority. Many customers they leave without saying anything. This is called the silent chunk. For example, someone may buy like for a while, but then they suddenly stop, and the business may not notice. So that's why we need a smarter method to detect customers who are likely to leave or who are likely to focus as the business. To solve this problem, we design an intelligent workflow that combines the machine learning with human decision making. So the system first it identify customer who are likely to churn, and then they will highlight the high value segment. This also generates product recommendation, and then the managers or our target user will use this information and take action. In this project, we use a huge transactional data set and product data set, like from 1.8 billion user. So in this data set, there are two big problems that we have found. The biggest problem is the loss-making transaction, which directly affect the model. Um, to solve this, we create like five variable or formulas to detect a loss-making transaction. So basically, a transaction make loss when the landing price is much more than the actual cross sale, or the discount rate is greater than the loss threshold. For the feature engineering, we transform raw transaction data into customer behavior features. Um, for example, we calculate average days between orders, number of unique products, and pre-purchase rates. We all know that good features are very important because they strongly affect the model performance. So we can see that most of the customer they only buy once or twice, and the at-risk customer they show high variance in purchase before they stop buying and leaving the business. We group in customer using the RFM framework, which stands for recency, frequency, and monetary value. These variables are highly skewed, so we first apply the Gale-Johnson transformation first, and then we will scale the data using the standard scaler. So using the elbow method, we choose 4 as the optimal cluster for the K-means segmentation. After segmentation, we have 4 roof, and in this project, we will focus on the at-risk customer to um, to the churn prediction. Okay, we will move to the churn prediction. We define churns as a customer who were active before but make no purchases in the next 50 days to the snapshot day. So that will our turn us to the classification problem, which is junks or not junk. We'll use 3 models, and the XJ boost is the most perfect give the performance. A junk, the junk probability for a specific user, if the customer have like greater than 80% junk probability, then they have very high to leave the business. So with this risk score, the manager, the marketing manager will notice, and they will make the decision to enhance this type of customer. We use shape model to understand why the model predicts churn, and it shows how the feature increases or decrease the churn risk. We also find that the variation in days between orders is the strongest churn signal, and this helps make the model more transparent and easy to trust.
Now I'm going to explain our recommendation engine. So we choose ALS, alternating list squares, because it's optimized for implicit data like purchases. Our technical edge lies in how we prepare the data. First, we calculate a confidence score that balances purchase intensity with exponential time decay, ensuring recent actions carry more weight. Secondly, we apply BM25 normalization. This penalizes globally popular items like generic bestsellers, forcing the model to learn unique, latent user preferences using 128 factors. In our recommendation engine, we adopt a hybrid strategy, and it's because pure predictive models often miss the obvious. A discovery-only approach frequently ignores immediate replenishment needs for favorite items. Take customer 001 and their regular Cadbury purchases as an example. Our hybrid approach solves this by perfectly balancing the comfort of top historical buys with the novelty of ALS predictions. And to evaluate our recommendation engine, we measured using the hit rate specifically on our target at-risk segment, and the results validate our approach. The hybrid strategy significantly outperformed the standalone discovery model. As shown in the chart, combining historical context with predictive modeling delivered a massive 2.5 times lift in successful re-engagement recommendations. For our system architecture, this slide illustrates how we operationalize our three models into a complete end-to-end architecture. First, we have the front end. We use React.js as our front end with the dynamic dashboard UI. And for our back end, we separate it into two parts. First, we have the offline training pipeline, where our raw data goes through the pre-processing steps as we discussed, and the three models. And the second part is the online inference engine, which we built by using the fast API. It loads the pre-trained models into memory to serve real-time predictions with sub-second latency. And finally, we deploy our architecture, our full stack architecture with Docker and Render Cloud. However, currently we are using the free plan of Render, and we cannot import the our three models, as our three models are too heavy for the free plan. Now I'm going to show you our demo from the web that we made. This is our web. We have three pages. So first one is the customer analysis, where we can analyze a customer. Let's take an example of this customer, and this is what our web returns. First one is the churn risk prediction, the chart. This is the recommendation engine, and this is the information of the customer, where the customer ordered 322 times, and our segmentation engine returns this customer as the champion cluster, and this one is the favorite purchases of this particular customer. The second page is the global overview of the dataset itself. As you can see, we have the global overview of the revenue, orders, unique customers, and average order value, with the revenue by category, revenue and activity trends, and the recent platform activity. For the third page is the most important page of all. It's the model analytics, model intelligence and strategy page, where we see that the best churn model is the XGBoost, and here we also have the SHAP global feature importance, and we have the platform clusters of the result of the segmentation. We have the churn model benchmarks, and here is where the admin of or the user of this web can send an email to high value priority customers that are identified as highly churn and at risk segment. So if we press the button here, we can see that this our web returns product recommendation, and targeting this customer, it generates the top 10 product recommendation using the ALS and hybrid strategy, and the user can send an offer email to this customer, so this customer can repurchase from the business. So that's all for our web demo. Back to the slides. This is our business model canvas with our value proposition of operationalized retention with data-driven customer engagement. And our key activities are model training and real-time inference with the customer segments of e-commerce platforms. Our unique selling point is when traditional analytics tools still uses Power BI or Excel shows data in passive or needs a 2+ years of data, our solution shows action which is active and works with 4 months of data. Looking ahead, we have identified key areas for future evolution, and current state, we have the human in the loop with manual review and action of the user as I showed before. And for the evolution, our future state is where we do real-time triggers using API integrations such as SendGrid or Twilio, where they automate engagement with personalized messaging and 24/7 retention engine. For the conclusion, our group has successfully transformed raw transactional data with the models and approaches we have mentioned to a profitability engine with a 2.5 times lift in hit rate. So stop burning money on generic marketing and invest intelligently in retention. Thank you for watching our presentation video.